In Chapter 4, we will discuss 5 types of orthographic drawing: view selection, alignment of views, orthographic writing steps, basic dimensioning, lastly, tangency and intersections.
In orthographic drawing, views refer to different two-dimensional representations of a three-dimensional object from various angles, such as front, top, side, rear, and bottom views. The selection of these views is the process of choosing the most appropriate and essential views to depict an object clearly, efficiently, and comprehensively. This careful selection of views is crucial for conveying accurate information and facilitating the manufacturing or understanding of the object in engineering and technical drawings. Ladies and gentlemen, I am pleased to introduce Christelle Mante, who will elaborate on the critical topics of views and selection in orthographic drawing.
Orient the object to the best position relative to a glass box. Please arrange the object in the best possible spot from which you will receive the most details when drawing orthographic projections. Select the front view. Select adjacent views like top view and side view. Step 1. Orient the object. The object should be placed in its natural position. The object should present its feature in actual size and shape in orthographic views. Here is an example. As you can see in the second pic, here the object is placed in the incline. The reader will find it difficult to understand these lines because the object is inclined when you try to draw an orthographic projection like a right. Now, look at the picture 1. Here you can see the object is placed in horizontal position. Now that you can see the front view, side view, and top view. That is the best position to be in because it allows you to orient the natural position, which will show us the actual size, form. Step 2. Select the front view. The object's longest dimension should be presented as width. Take a look at the first choice. So this is a car's dimension is length and width, and it wastes more space. So we'll choose the second option. We can easily see the front view, side view, and top view. So the second choice is good and the first choice is inappropriate. Step 2. Select a front view. The adjacent views that are projected from the selected front view should appear in its natural position. The top view, front view, the other person can identify which view is this, but you can say this is an inappropriate. It should be placed in its natural position. This is the drawing, but that is not good for the reader or for the drawing. It should be placed in good position. Choose the view that have the fewest number of hidden lines. Try to place or take as a front view which have minimum hidden lines. Take a look from the first picture. So here is an object. We are seeing all the holes from this side. When you will see from the front side, you will see this hole as a referral, and this hole, when you will see from here, will be appeared as hidden line now. The second, the view is placed in the opposite direction, means the rear view is now this longitudinal view will be front view. Here, when the observer will see here is a cut behind in this view, we need to draw more details of hidden features. So the first pick is good and the second pick is inappropriate. Next, step 3. Select an adjacent view. There are multiple options. This is a front view. You can take top view, right side, left side, bottom side, rear side. So which view are the best? Here, that is the right side view. When you will see from the right side, this hole will also be in the hidden line. And this hole that is in the L shape, that will be also hidden. This is the right side now. Here, you can see from left side, this is the left side view. When you will see from the left side, this intersection will be hidden. So here, that is shown with a dashed line. So this left side view is inappropriate. So this right side view is much good. So now here you can see the top view, and here is the bottom view from downside. When you will see from the bottom line, you will not able to see this card, so you will also draw hidden lines. Here similarly, you will not able to see this card, so this card will also be shown with the hidden lines. So that why here hidden line is shown that the dot represents this dash and this card represented by this dash, so that is not appropriate. The first is a good one. Top view, lesser number of hidden lines. Choose the view that have the fewest number of hidden lines. Means there is not necessary that always draw the 3 views. Sometimes 2 views are enough for the description of the object. Now you can see this dimension, the L shape is shown here. Next, the hole that is shown in the top view. Hole's location can be specified in the same view. It's easy to understand. And below, it's indicated as inappropriate is difficult to interpret. So the first one is good. Step 3. Choose the views that are suitable to a drawing space. So there are options that we take. This is your front view, and when we'll see from the top view, this will be shown. As it says, not enough space for dimensioning. So when we write the dimension, like what is the millimeter dimension of this dia, what is the length of this piece, we have not much space. Now in the drawing, which is the good position? This one is inappropriate or poor. This one, you will see the right side view, and there is much space for dimensioning. This is a triangular wedge piece or 3D piece. So here, this is a front view, which when you see from the front view, you will see as a box. You will get the dimension, width and height. For this side, when you will see from the top, you will see this dimension. This is the depth, and then you will see from the right side, you will understand there is a triangular shape, but from this top view and front view, you can't understand. Either it's a wedge or it's a triangular or what's, but it is either it's a box. So how size and shape? Size is okay, means you can get the dimension width from here, height of this object from this front view, and what will be the dimension. You are getting all 3 dimensions, but you are not getting the shape description. It may think that either it is a box, or when you draw the top view, will be like that. When you will see from the front, it's different view will be like that. The other person may think there is some curve, so it is necessary that for this object, write the right side view. You got the idea that it is a triangular shape. 3 views, size description and shape description is okay. And if we draw only these 2 objects, then we can also understand this is the object and the width of the object. This is so only with these 2 views we can draw this 3D object. So there are also some drawings where only 1 drawing is enough. Here you can see, when you will see from the top view, you will see this hole, this bigger hole, this semicircle, and when you will see from the front side and the right side, here from the right side and front side, we almost got all the dimensions. From the top view, instead of thickness, we can just mention the thickness here. These two views provide only information about the part thickness, so we can omit that this is unnecessary. We will draw only one drawing and mention that what is the thickness of this object. So that is a 1 inch thick. So this is a one view drawing. Again, take one example, cylindrical shaped part. Okay, so that is a top view, front view, and the side view. From the side view, that is a circle. Here, repetition. This is a repetition, so we can commit 1. So now, inner infer from the center line. When there is a central line mentioned, it is understandable that this is a circle. So here is also mentioned the center line. So this is unnecessary. And with this drawing, with the mentioning of center line drawing, for these cylindrical pieces will be okay. Now for this object, so when you will draw this object drawing and you got there is a center line and the hidden feature, will also over the circle, so that is also enough for this part. Two view drawing. Here this drawing have 5 holes. Then you will see this side, from that is the front view. So here you got all the dias of circles. So here are the 4 circles. So here now we need one view, which is either from the right side or from this view, from the top. You can see the both views are same, this view and this view, so you can commit one drawing. That is a repetition, so these trying 2 drawings are enough for descriptions of the subject. You can write the description, thickness, dias of circle, etc. The 3D view has no significant contours of the object. Here, when you will see from this side, that is the front view, and when you will see from the right side, you got this view, dash line, here in the lower solid part, and there is a circle, bigger circle in this upper part, from this solid line to upper part, dash. That is a symbolic representation of center line. So when you will see from the top, these circles and the bigger circle will be hidden. So now that is unnecessary. Why you will get the length of this object. So length of object is like what a curve. There are 2 holes that are present at the bigger hole. All the dimensions you can mention clearly on these 2 figures, so this view is unnecessary. From this side, that is the front view. And when you see from the right side, you got this view, dash line on the lower solid part, and there is a circle bigger in this upper part, from this solid line to upper part, dash. That is a symbolic representation of center line. So when you will see from top, these circles will be hidden. So now that is unnecessary. Why you will get the length of this object. So length of object is like what a curve. There are 2 holes that are present at the bigger hole. All the dimensions you can mention clearly on these 2 figures. So this is
In orthographic drawing, lines are used to define the edges and features of objects, including visible lines, hidden lines, center lines, and dimension lines. These lines help convey the shape and dimensions of the object. Views, on the other hand, represent 2-dimensional projections of a 3-dimensional object from various angles, such as the front view, top view, and side view. Christelle Mante, who will guide us through the essential topics of lines and views in orthographic drawing, pivotal for representing objects with clarity and precision.
So this is the first quadrant, second, third, and fourth. So place the object in the first quadrant. Here, now draw its front, top, and side view. So here, when you place the object in the third quadrant, that is a third angle system. Now, I will go in detail what is the difference between in the first angle and the third angle. Here in the third angle under the box, that is the front of box. Now see what was the difference in the first angle and the third angle. There is a minor difference. When you will see this from this side, you will see this face here and this bottom part in here. Same view will be drawn at the third angle. You will see this here as the front face. Here, this. Now, if the observer will see the first angle system from this object, this, there is some hidden lines. This shown with the dash line here. Now, same here in the form of this side here. Now, the hidden feature here in the center. From the top view, from the top view, observer comes above this plane here at the top. Remaining part now, same way in the third projection with calm upward plane. Now I will open these boxes by placing pins or hinges. First angle system and the third angle system. So here, this is the first angle and the third angle. So now you got these three views here and also here. So this is the folding line. We need to cut it here. So when you open or cut this, it's going to be like this. So this is the arrangement of views. So you can see this is a top view, right side view, and the top view. In the first angle, this is the right side view, top view, and top view. The first view and the third view is just the arrangement of views, although we must follow the third angle system. Here both are the same, but the difference is the alignment. So next is orthographic writing steps. Writing steps. Select the necessary views, lay out the views, project the views, and dimension the views. Select the necessary views. So there is a multiple option. Either we have this front view. This is a front view. So we will longer dimension. We will take this as a front view. From top view is for a top view. Okay. The longest side we taken this as a front view. That is a top view. So here is the object, here is the dimension, that is the length, height, and width. Okay, here so much space. We need to draw this object, 25 millimeter gap, top view and front view. Now, this is the drawing space where we will project the views, like front and top view. It is the width and the length of this piece, and in the front view, length and width of this piece. So, guideline is drawn here, as you can see, for drawing on this semicircle. So, here you can see the whole top view is drawn successfully with the helps of these guidelines. So, for the for the front view at the top will be same location, that circle hidden lines. And you will see from the front side, this is much height. So how much the height is horizontal is drawn. Will be there is a cut in here. The hidden circle that will not be shown with the hidden line. You will not able to see from the side hidden features. This card will also be invisible from this side, from the front view that will be shown with the hidden lines. Now for the inner circles, and this card here, so now the center line for this bigger center, similarly for this small circle. In the vertical, as, as you can see, there is also a circle continuation here, the red line. There is also an arc at the center line. So then you can name the part name here. Dimension are in millimeter, or can also help of dimensioning, right? That is the length, width of the circle. What is this cut? All things you can mention with the help of dimension.
In orthographic writing, basic dimensioning is a technique used to specify the size and location of geometric features in a two-dimensional representation of a three-dimensional object. It involves providing essential measurements for key features, such as length, width, and height, typically using numerical values and units of me. Kevin will share insights on the fundamental principles and practices of basic dimensioning in orthographic drawing, a cornerstone of precise technical communication in engineering and design.
So, basic dimensions are theoretically exact numerical values to define the form, size, orientation, or location of the part of the feature. Basic dimensions are usually shown on a drawing enclosed in a box, but they can also be invoked by referencing a standard or by a note on the drawing. So the basic dimensions have five components. So these are extension lines, dimension lines, leader line, dimension numbers, and local notes. So here is the illustration on each example. Example, extension line. Extension lines are used to define the beginning and the ending points of the dimension. Dimension lines display the measured element's length. Leader line. It is a thin solid line with an arrow under it that points to the feature to the dimension or comment. Refers to dimension numbers or numeral dimension numbers. Should be centered between arrowheads, except when using stacked dimensions, and then the numbers should be staggered. Local notes. Drawing often have notes attached for more information. They should be placed on a sketch in a quiet area. Be succinct and will face to prevent being misunderstood. So, why basic dimensions or the components are very important? Because it gives us information about the both size and shape, and the object must be available. The exact shape of the object is communicated through orthographic drawing or writing, which are developed to following standard drawing practices. The process of adding size information to a drawing is known as dimensioning of the drawing. Basic tangent and intersections. Tangents and intersections
Tangencies
in
and
orthographic
intersection.
drawing serves to convey
In
technical
orthographic drawing,
information about
intersections and
how
tangencies refer to
different
important
components
geometric
of an object
relationships between
interact in
various features or
three-dimensional
elements
space.
within the drawing.
They play a central role in
Intersections occur
ensuring
when two
accurate
or more lines,
manufacturing, smooth
planes, or
assembly,
surfaces
and
meet or
effective
cross each other.
communication of design
These
intent.
intersections are critical in defining the shape and boundaries of objects accurately.
So here is the example
Tangencies, on the other
on
hand,
each
represent
illustration of
points or
tangent
lines
and
where two
intersection.
curves or surfaces touch each other
So
without
no line is
crossing.
formed when a curved surface. Line is formed when the curved surface intersects a plane surface. A tangent is a line with the plane of a circle that intersects or passes through the surface of a circle. So, intersections refers to the point or line where two or more geometric elements such as lines, surface, meet or cross to each other. In orthographic drawing, it intersects are often indicated to accurately represents the relationships between different features of the object being drawn. For example, if you have two lines representing edges of 3D object that intersects the point of intersection will be shown in the orthographic view to illustrate how those lines related in three-dimensional space. Tangencies or tangent refers to the point of contact or points where curve or surface just touches another curve or surface. An orthographic drawing shows that tangencies accurately is crucial when depicting objects with smoothly curved surfaces and objects that are in contact with each other without overlapping. Tangent points help convey how different components of an object are situated in relation of each other. Orthographic drawings often include the multiple views: front, top, side, view, and etc. to provide a complete, accurate representation of an object's shape, size, and features. Intersections, points, and tangencies are essential details that ensure that the drawing communicates the spatial relationships and connections between the different parts of the object, aiding manufacturing, constructions, or the technical applications. These details helps engineers, architects, and designers to understand how the object's component comes together in three-dimensional space.